In this video, we will learn about how to encode a message using arithmetic coding. Suppose we have a source which emits the symbols A, D and the exclamatory mark. And suppose we have the probability given for each of the symbols. For example, for A we have 0.4 and for D we have 0.1 and for the exclamatory mark we have 0.1. Now we have to encode the message which is DAD exclamation using arithmetic coding. We are trying to find out a code word which corresponds to this message. Now in the first step, I want you to draw a line like this. Denote the upper level as 1 and the lower level as 0. Since we have three symbols which are used here, which is A, D and factorial, we will subdivide this line into three blocks. Now the first part, let's name it as A, and the second part let's name it as D, and the third part is factorial. Now we want to find out the values of this middle lines present between 0 and 1. Now since this is the first step, we can directly write the probabilities which are in between this 0 and 1 from the probability of the symbols which is given to us. So the first line will have a probability of 0.4, and in the next line which is present here, you have to add between these two probabilities. So 0.4 plus 0.5 is equal to 0.9, so we have to write 0.9 here. Now we have to look at what message we want to encode. The first letter of our word is D. Now I want you to imagine as if I'm going to take only this line 0.4 to 0.9. I'm going to exclude 0.9 to 1 and 0 to 0.4. So I am going to only consider this line. Now for this line, the upper limit is 0.9 and the lower limit is 0.4. Just like how we divided the previous line into three subparts, we will also divide this line into three subparts, each containing the same three symbols. So 1 and then 2. And we should write what are the letters corresponding to each subpart. So first we will write A, and then here I will write D, and then here I will write factorial. Now we want to find out the values of the middle lines here. How do we do that? First thing which you should do here, you should calculate the difference between the upper limit and the lower limit. The upper limit is here and the lower limit is here. So the difference denoted by D is equal to the upper limit minus the lower limit. And that gives us 0.9 minus 0.4, which is 0.5. Now to calculate the first line here, you have to take the lower limit here. So the probability of A, which is this line, corresponds to the lower limit 0.4 plus D times the actual probability of that symbol given in our question, which is 0.4. So now we can tell 0.4 plus 0.5, which we found out, into 0.4. 0.5 into 0.4 gives us 0.2, and then adding this we have 0.6. So 0.6 is the value of the first middle line present here. Similarly, we have to calculate for the second middle line. For that, probability of D is equal to the lower limit which is now present for this line, right, is 0.6. So 0.4 is for the probability of A, which is the lower limit here. But now the lower limit is 0.6 plus the D, which is going to remain the same, which is 0.5, and the probability which is associated with D in the first place. So it was 0.5. Okay, and now we have to calculate this. So 0.5 into 0.5 is 0.25. So 0.6 plus 0.25 is 0.85. So 0.85 is the value of the second middle line. Now the word which was given to us was DAD. So the first thing, D, is completed. Now we have to take A. So now the line segment which corresponds to A is this one. So we will again construct a line which has the upper limit of 0.6 now and 0.4 as the lower limit. Okay, and we will also divide it into three subparts and write the subpart names also, A, D and factorial. Now again we want to find out the middle values. So we know that the upper limit, the difference we have to calculate first, which is U minus L, is nothing but 0.6 minus 0.4 is equal to 0.2. Okay, now we will calculate probability at A is equal to the lower limit, which is 0.4, plus D, which is 0.2, into the probability which was associated with A first, which is 0.4. And if we add this, we will get 0.4 plus 0.2 into 0.4, which is 0.08. So 0.4 plus 0.08 is equal to 0.48. So the value here is 0.48. Similarly, we have to calculate for probability at D, and for that we have to have 0.48 is the lower limit here plus 0.2 into the actual probability, which is 0.5. And then now we have 0.48 plus 0.2 into 0.5, which is 0.1. So we have 0.58 here. We have 0.58 here. Now we have got D, A, and now we have to again continue for D, because that is the third letter of DAD exclamation. So we have to again extend this line and form a line segment here. And now we have the upper limit is 0.58 and the lower limit is 0.48. We will again separate it into 3 subparts and name it A, D, and then factorial. Now again we have to find out what is the middle values. So here we can see that the upper limit D is equal to 0.58 minus 0.48, and that is equal to 0.1. So now we have calculated the difference. Now for the first one, which is probability at A, we have to take the lower limit 0.48 plus the difference 0.1 into actual probability which was associated, which is 0.4 to A, and then 0.48 plus 0.1 into 0.4 is nothing but 0.04. So we will have 0.52 here. So the value which is associated here is 0.52. Similarly, we have to do it for D also. So probability at the end of D is equal to 0.52, because the lower limit is now 0.52 plus 0.1 into 0.5. So now if we add this, so 0.52 plus 0.05, which is nothing but 0.57. So our value here is 0.57. Now we have the fourth symbol, factorial. But we don't need to do the same thing for the factorial, because we know that the value or the code word of that factorial will lie between 0.58 and 0.57. So we don't have to again separate it into 3 subparts and find out the middle values. What we should do here is that we will find something called tag. The tag is nothing but the average of the upper limit and the lower limit. So 0.58 plus 0.57 divided by 2. Now this tag will result in a value of 0.575. This 0.575 is the code word of our message. So we have got the encoded message of DAD factorial by using arithmetic coding as 0.575. This is the answer, and this is how we perform arithmetic coding if you are given a message and a probability of the sources emitting each of the symbol. Thank you.